This is Joe narrating a PowerPoint. It's from Science, the unit on science practices, Lesson 1, Comprehending Scientific Presentations. On the science, social studies, and math exams, you'll see many examples of text with graphics. Graphics are pictures. That might be a graph, might be a diagram. You should be very familiar with how to interpret them and how to interpret them quickly. For example, if you're shown this diagram, you would look at it and figure out that it's a TV remote control, and the diagram is attempting to show you what the different buttons work. So it's showing you the structure of the remote control and the functions of each button. So if you were to put a heading on this image, what would you say? This is a diagram of flower structure. So just like the remote control, you have a bunch of words you might not have heard of, but you can follow the arrows to where the parts of the flower are and give each flower part a distinct name. Again, you won't have to know the parts of the flower for the GED exam, but you should be able to interpret a diagram and figure out what they're talking about. Let's say there was an experiment where a researcher left an orange, a kiwi, a banana, and an apple out on a counter and wanted to determine which one had the most mold or fungus growing on it after a certain amount of time. So you would study the 4 fruits, maybe a couple of each fruit, and then you take the average amount of mold on each orange, each kiwi, etc., and then you would graph your results. In this graph, you have the different fruits on the x-axis, and then you have the fraction of fruit covered by mold on the y-axis. So in the oranges, 9/10 of the oranges were covered with mold after that time, 6/10 of the kiwis, less than 1/10 of the bananas, and about between 2 and 3/10 for the apple. So in this one graph, you show the results of an experiment, and you would know that oranges get moldy much quicker and to a greater extent than bananas. Similarly, if a beach community was trying to figure out how to eliminate trash on their beach, they might do a survey of the trash that's left on the beach. Here's a pie chart of the different trash items left on a beach. 40% of the trash is made up of cigarettes. So one thing the beach might do is ban cigarette smoking on the beach. That would get rid of 40% of the trash just from that simple step. So a scientific analysis of data is helpful in real-life applications. Another research idea might be to look at the number of plants in a pot and how does that affect the growth of the plants. On this line chart, you have days on the x-axis, and you have plant growth in centimeters of height. And the question is, how does the number of plants in a pot affect plant growth? So the blue diamonds represent 1 plant per pot. The pink squares represent 2 plants per pot. Black triangles, 3 plants per pot. And the red squares represent 4 plants per pot. And you can see that at the end of 40 days, the plant growth with 1 plant per pot was 50 centimeters on average. And for example, at 4 plants per pot, it was about 22 centimeters of growth. So the answer to your question that you had in the beginning, how does the number of plants in a pot affect plant growth? The more plants in the pot, the less growth results after 40 days. You will also need to understand scientific shorthand. So for example, in chemistry, you will have what's called a chemical equation, where you have reactants, 2 molecules on the left in this case, and they interact to form products, two different molecules on the right. You'll have to know that reactants are the compounds on the left side of the arrow and the products are the compounds on the right side of the arrow. So this is a shorthand way for chemists to describe a chemical reaction. You might also learn what are called mnemonics. Those are memory devices to remember the main ideas. For example, one mnemonic for remembering the keys to evolution is the word vista, V-I-S-T-A. So to have evolution, you need, first of all, variation. You need inheritance. Those different traits need to be inherited. You need selection. Nature will select out, for example, slow-moving deer rather than fast deer. You need enough time for changes to happen, and this time period might be hundreds of years, thousands of years, or even millions of years. And all these four factors, variation, inheritance, selection, and time, cause adaptive change. Adaptations are changes in the body or the structure of the body or the functions of the body that allow an organism to be better able to survive and reproduce in a given environment. That's